going to talk about the agent tunneling. And this is going to be, man, let's see. This is going to be super. Okay, so right now I have, right. Okay, so I already have K3s running here. So what I'm going to do is I just need the IP address of this machine, use the private network. Okay, I'm going to go over to another node here. Just make sure I can talk to that one. Okay, and I'm going to join this one to the other node. So I'm going to have a master, like the control plane node, and a worker node. You can pass a bunch of arguments and stuff to the shell script to configure. I highly recommend you go with the config file approach to configure and manage K3s these days. So this is covered all in our docs and everything. But there's just a file in here as config YAML. And the format of this file exactly matches the parameters. Like on the command line, if I was to type like K3s server -- server foo, it's going to be exactly the same. Like the parameter here is going to be, oh wait, server was a bad example because I just repeated that twice. But so the parameter in here is going to be token, foo, like that. So it's like there's an exact one-to-one correlation between the CLI arguments and what goes in the config file. But for me to join a node, I just need the node token here. Let me copy this over. Okay, so I'm going to set up this. So I've got this config file in place. I'll show this again just so you see what I did here. So it's an etc rancher K3s config YAML. I just put the token in server. I did the server wrong. Hold on, let me edit that. The server needs to be the HTTPS, the URL, not just the IP, 6443. Okay, all right. So that's the token in server. And now I'll install K3s, just using the shell script. And so the one little catch is you do this, you say -s. What this -s does is it means tack on arguments to the install script. There's also env vars and a bunch of other things. Like if you look at the shell script itself, this is all documented in the shell script, like all the parameters and everything. So if you ever want to know how to use the install script, just download it and read it. It tells you all the magical arguments to it. But here I'm just going to do -s agent. So this is going to install it as an agent, and you'll use that config. So now if I go back over to the kubectl get node -- watch. Okay, so hopefully, usually it's about less than like about 15. Yeah, okay, so that's coming in. It's usually about 15 seconds to like download and join a node and for it to become ready. So this node has come in. Let's just give it a couple seconds. Okay, so it's ready. All right, so that's how fast you can install it and add an additional node. Okay, so what I want to talk about is the agent tunneling. So this is like a major, so in order for K3s to work, the networking, you have to have a bidirectional communication from the nodes to the control plane. And so you need, that means the control plane needs to be able to make a connection directly to the kubelet, and the kubelets need to make a connection to the control plane. This is a pain in the butt to set up in a lot of environments, especially when you're doing like weird heterogeneous setups. So because you have to worry about firewalling, like it's always easier to make an outbound connection than to allow inbound connections. So we run into issues from Rancher as we've supported Kubernetes over the years, just getting a lot of the networking and DNS and host name and all this stuff set up properly causes a lot of people problems in getting Kubernetes. So we wanted to work around all these things. So what we do is we actually have this tunnel, this reverse tunnel running from the nodes to the control plane. And so the nodes only make an outbound connection to the control plane, and then the control plane can use this reverse tunnel to talk back to the nodes. This is all done through this one project in Rancher It's called Remote Dialer. Super low level. I can't imagine anyone be able to understand and use this project. This is actually used internally also in Alex Ellis's Inlets project. He uses remote dialer for some of his stuff there. And we've used this extensively also in Rancher. It's a pretty battle tested thing or whatever, but it's not a pretty piece of code. I wrote a lot of this code, and I'll tell you, like, the APIs are just terrible. But anyways, but it seems to function. So so I want to demonstrate like how this is working here. So if I look at what are all of the listening TCP connections on this host, so you can see here, okay, the majority of the connections, like these are a bunch of random things. The majority of the connections, like a lot of these have to do with what's running on the host, kubeproxy, kubelet, and whatnot. We really wanted everything to be listening on localhost. We didn't want anything exposed publicly. Unfortunately, Kubernetes kind of requires that the kubelet has to listen, has to open up this port to 10.250. So this port is open, but I will ensure, like, I will say it is completely authenticated and secure. I can show you that here. When we run the kubelet, the things that you want to look for is anonymous auth is false, authentication is webhook, authorization is webhook. And so it's running on TLS and it's fully authorized. So that port is secure. But we ideally would like that to be listening on localhost, but for metrics, it has to be running. But so what I want to show you is, so if I go into this other host here, let me get the address of this one. IP address, IP address show. Okay. Okay. If I curl this, 10.250, right? Okay. So I'm just proving right now, like that port is in fact open, but it's giving me a 404. If I actually tried to go to something, it will give me, it'll give you an unauthorized, but it is secure. So, but what I'm trying to demonstrate here is, okay, so here from the node, because I'm on the same network, there's no firewalling issues. I can just directly hit the kubelet on the worker node. So this tab here is the worker node. This tab here is the control plane. But if I go and I block, if I block inbound to that, so let's imagine I was running through some firewall, like let's do some IP tables magic. This will block all new connections to 2550 that are not from localhost, and then we'll drop that. Okay, cool, that worked. Okay, so now if I run this over here, we should see, yeah, okay, so it's blocked off. I cannot connect to that port anymore, right? But in order to do something like a kubectl exec, I have to be able to talk to that port. So you can see here, let me find a pod. Oops, -o wide. Okay, so this pod here is running on that machine. So if I do kubectl exec, namespace kube system, this guy. Okay, boom. Okay, so I got into this. So normally in Kubernetes, the way this works is the control plane will make an outbound connection to the kubelet to establish a tunnel to pipe through the TTY data or whatever. And here I've completely firewalled off that node, but I can still get access to it. And you can see the way that is working is 1025. Right here. It's this connection that just opened up. So you can see we are communicating through localhost. So it's all going through this reverse tunnel. Okay, so we set up all this reverse tunnel. So this makes like, so this helps with logs and exec. Those will automatically, like those will be, they work through this or whatever. So it's like one of the things that people will ask is like, why don't we use kubeadm? We don't, because we don't use internally, like we don't provision, like what kubeadm is, it's called basically, it's kind of been classified now as a Kubernetes bootstrapper. is like, in order to start Kubernetes, you need certificates, you need arguments. That's largely it. It's like to start Kubernetes, you need a bunch of certificates, and you need all the proper arguments to the binaries. And kubeadm is a bootstrapper that will generate certificates and generate the arguments and kind of bootstrap Kubernetes. K3s does not use that. And the reason why we don't use it is not that like I have any issue with kubeadm. It's that like we want to bootstrap a heck of a lot more stuff than what kubeadm does. Like I would like to be able to wrap or leverage a lot of the kubeadm stuff, and we're trying to do that right now. We have some efforts going on to figure out how we can leverage more of kubeadm. But fundamentally, what we do with K3s is significantly more. So this is one of those examples. Is like, well, we're also running like these reverse tunnels and all of this stuff that kind of sits below Kubernetes. And so that's why we have like our kind of our own technology or mechanism on how to bring up the whole system to accomplish things like that, like this. Because so, okay, so let me go through. I mean, how long? So I'm 40 minutes in. I had no idea I was going to talk this much.
As far as I'm concerned, you can continue this all night. This is super interesting. So
yes, I mean, if literally, if you don't mind, I can go easily for like another hour. If people get bored, I don't know.
So, I'm on board. I'm learning lots. So yeah, keep going.
Okay. So this is how we're doing the tunneling or whatever. So let me but I will say, like, the one downside, because I said Kubernetes does require that port be open, and since I blocked off that port, where you'll see that manifested is if I say, oh wait, no, oh, here, this is the reason why this is still working is I never restarted, because I just blocked new TCP connections. I didn't block established. So if I actually restart the agent here, you'll see then. Yeah, the number of connections is down here. And now if I look at this, within probably about 15 seconds, I think, you'll see that the stats for this node will drop offline. That's why we have to, unfortunately, open up that port still. Like I can't just listen on 127 because of the way that people grab metrics like from Prometheus and stuff like that. They're assuming you can hit that port publicly. Eventually, once the metric server, there it goes. Okay, yeah. So you see, it drops it because it can't connect to it anymore.